Okay, let's look at example 1.4. Please turn to page 12 in your textbook. Let's read the question first. Kundasan Lake, with an area of 55 kilometers square, had a water elevation of 110 meter at the beginning of a certain month. In that month, the lake received an inflow of 6 meter cube per second and outflow of 6.5 meter cube per second. The lake also received a rainfall of 145 mm and the rate of evaporation was estimated to be 70 mm. So based on the information given, calculate A, total inflow at the end of the month, noted as I, B, total outflow at the end of the month, noted as O, and change in storage at the end of the month. Okay. So first thing, you have to list all the information as given in the questions. On first sentence, you can obtain that area given is 55 kilometers square. And then water elevation is 110, you can note it as H. And then delta T. Delta T, 30 days. Why is we use 30 days? Because in this question, it stated that month, certain month in that month, so it happened throughout the whole month. So we can conclude that delta T equals to 1 month or equals to 30 days. Average for 1 month is equal to 30 days. And then for inflow, the first inflow is I1 is 6 meter cube per second from the second sentences here. And the outflow also given as 6.5 meter cube per second. Okay. The next statement or the next sentence, it gives you rainfall. Rainfall received equals to 145 mm. So we can note it as P equals to 145 mm. And then rate of evaporation is 70 mm, LE, 70 mm. Okay, to understand this question, firstly you have to identify all the information given as we go through just now. So you must also understand what is the question, the intended question in this exercise. So we have overall 3 questions here: total inflow, total outflow, and change in storage. Okay, from the information we can assume that the following equation will be used. So based on the information here, we have I1, O1. And then for LE, we can consider it as the outflow at the end of the month. LE also can be considered as outflow from the system. And then precipitation also can be considered as inflow to the system. So we can conclude that LE is O2 and P is I2. So we have I1, I2, O1 and O2. So you can use equation number 4, which is I1 plus I2 divided by 2 minus O1 plus O2 divided by O2 equals to delta S over delta T. Or you can say as I1 plus I2 divided by 2. This equation is for total inflow. This equation can be considered as total inflow, and so do for this outflow equation. This one can be considered as total outflow, and this one is rate of change of storage. Okay, so this as I mentioned just now, so we can consider I1 plus I2 minus 2 equals to total inflow. O1 plus O2 minus 2 equals to total outflow, and change of volume in the system is delta S over delta T. Okay, let's go through question A first. So information needed is I1 and also I2. Based on the question you obtained just now, the information we have listed, I2 equals to 6 meter cube per second and P equals to I1 or equals to 144 mm. So if you look at this equation, the mathematical operation involved is plus. So when you want to plus something with something, you must make sure that the unit is the same. So here you have a different unit between I1 and I2. So what you have to do is you must change one of the unit to be equals to the next one. So in this case, I choose P equals to 145 millimeter to be changed to meter cube per second. So let's change one by one. Okay. So first we have to change mm to meter first. So to convert 165 mm to meter, so we have to divide by 1000 because 1 meter equals to 1000 millimeter. So 165 divided by 1000, you get 0.165 meter. Next, convert, or you have to divert meter to meter cube. So meter is meter power of 1 and meter cube is meter power of 3. So the difference between meter power of 1 and meter power of 3, the difference of power is equals to 3 minus 1 equals to 2. So you must look at the information. What will give you, what information will give you a unit in meter cube. So in this question, the given area is in 55 times 10 power of 6 meter cube. 55 times, the given area is 55 times 10 power of 6 meter square. So this one we can multiple with the value we have obtained just now, 0.16 meter. So 0.16 meter times 55 times 10 power of 6, you will get 9.075 times 10 power of 6 meter cube. Okay, that's not all, but you have to change. Okay, this one you already get the value in meter cube, but you must get the value in unit meter cube per second. So you must divide by something which is in second unit. So obviously it is for unit for time. Second is unit for time. So as given in the question, delta T is equal to 30 days. So from days you have to convert to seconds. So this is how you convert days to second. So 30 days times 24 hours divided by 1 day times 60 minutes divided by 1 hour times 60 seconds divided by 1 minute. So at the end of the calculation, you will get 2.562 times 10 power of 6 seconds. So you already obtained the time in second and the precipitation in meter cube. So you can get the value in unit meter cube per second. Just take the value in meter cube over here and divide by the value for time in second as we calculate just now, which is 2.592 times 10 power of 6 seconds. So the value, the new value for I2 is 3.5 meter cube per second. So here you already have the same unit, so you can do the mathematical operation, which is plus. So I1 equals to 6 plus I2 equals to 3.5. So divide by 2, you will get 475 meter cube per second. So this is the total inflow for the question. Same goes to question B. How you answer question B is similar to how you answer question A. you have to convert the unit first, one by one, one step to one step. Convert to meter, and then meter convert to meter cube, and then meter cube convert to meter cube per second, and then do the same calculation process. So you will get the new LE equals to 1.49 meter cube per second. So when you get this value in the same unit, you can calculate total outflow. So at the end, you will get total outflow equals to 4.0 meter cube per second. Okay. So to answer question C, just use the equation for I minus O equals to delta S over delta T. So you just take the value for total inflow. Here, total inflow minus value for total outflow. So this one is value for total outflow. Okay, so you will get 0.75 meter cube per second. Okay, to answer the question, change in storage at the end of the month. So the notation is delta S. So I minus O equals to delta S over delta T. So you have to eliminate the delta T here. So we have calculated delta T before. So just use the value we obtained just now, which is this one, 2.562 times 10 power of 6 second. Okay, so you will get 1.944 times 10 power of 6 meter cube. So this is your delta S value. Okay, that's all. Thank you.